Hi, my name is Alexis Pister and I will present PK clustering, a system for integrating prior knowledge in mixed initiative social network clustering, a project with Paolo Bono, Jean-Daniel Fequet, Catherine Plaisant, and Paola Valdivia. We worked with social scientists who analyze corpus of documents mentioning people. They study the structure of the social network in great detail and often want to cluster their data. We propose PK clustering, a new way of doing graph clustering in mixed initiative setting, which aims to give more control to the user in the analysis loop. First, users specify some prior knowledge. Then, they consolidate the expanded prior knowledge clusters with the suggestions of one or more algorithms. Finally, they can consolidate extra clusters suggested by the system. Let's look at the demo. Imagine that I am a social scientist looking for groups in the simplified version of a social network of merchants of the 17th century. PK clustering works with node link diagrams, but I will demonstrate it using PowerVis. All the people are listed here, and each vertical line represents a connection between two or more people. Using existing clustering tools, I would randomly choose one algorithm in a long list of mysterious names, like Louvain. I would then pick parameters I do not quite understand, run the clustering, and look at the results. But how good are those 6 clusters? Typically, I scan the names to see how it matches what I know, or what we call prior knowledge. For example, I know that Marie Boucher and Jean Masson-Lesnay are friends, so it makes sense to find them in the same cluster. However, I think that Hubert and Marguerite Antome should be together in another group. We see here that it is not the case. I might try again with another algorithm, but would really prefer a more systematic method. With PK clustering, I first describe my prior knowledge by creating partial groups. I create a new group, add Marie Boucher and Jean Masson-Lesnay, and call it Group A. I then put Hubert and Marguerite Antome in another group that I call Group B, in red. When I start the clustering, all the algorithms implemented by the system are run automatically. They are ranked by how well they match my prior knowledge. The top 6 algorithms have a perfect match. Both persons of the prior knowledge group A are found in the same cluster, and the 2 persons of the second prior knowledge group B are together as well in another cluster. 2 algorithms have a partial match. Those algorithms did not match anything at all. The other people in each matched cluster are represented with these white rectangles and a number. The other clusters found by the algorithms are represented here on the right. I will start by looking at one of the most promising algorithms. I click on Louvain time. I see 3 groups, A, B, and others. The people from my prior knowledge are easy to spot. I can click on Others to see the other clusters in detail. But I would prefer to see how the top algorithms compare. The algorithms which gave a perfect match are selected by default. I select those 7 algorithms and click Compare. The 7 algorithms are listed on top along with the prior knowledge. By default, the first algorithm is used to group the persons. I can see that in group B there is a lot of agreement. For many people, all 7 algorithms agree. For others, only 3. On the other hand, the consensus is less clear on the blue group. Only two algorithms think that Jacques Souchet should be in that group. One algorithm even put him in the red group. At this point, I will go look at the network or read other sources to decide what is best. Using the consensus slider, I can select everyone with at least 4 diamonds the same color. They appear as circles in the consolidated knowledge column on the right. I then validate the suggestions by dragging or clicking on the circles. They turn into squares and will not change again. For the other persons, depending on what I learn from the graph or other documents, I can copy the suggestion of an algorithm. For example, I believe that these people belong to the red group, along with Jacques Souchet. Or I can just leave them undecided. I am done expanding and validating the prior knowledge clusters. Now, let's look at the other clusters. Clicking on Others splits the other people by the clusters found by the currently selected algorithm. I can compare how the different algorithms do that. The clusters found are ordered by consensus. If I hover over a proposed extra cluster, shown in green now, the similar clusters found by other algorithms are shown in green. If I agree with a suggested cluster, I can validate it by clicking on its name. I then can rename it. Then, I can consolidate this new group. I repeat with other clusters, but I can leave things undecided as well. Now, I have a consensual and satisfactory partition that considered my prior knowledge. Let's review possible biases during clustering. In PK clustering, users have a lot of influence on the results and can override labels when they know the labels are wrong, based on other data they have analyzed. Our users ask to be able to do that, but it could introduce some bias as well. Moreover, if the prior knowledge is wrong, the system will try to follow the hypothesis given by the user. However, users will also see that alternative results are possible. Traditional clustering methods have issues of bias as well. Users can be primed to believe the results of the first algorithm they try, and accept results which are not necessarily good. They also often use prior knowledge to evaluate the results. Finally, they often try only a few algorithms and could miss interesting alternative clusterings. To increase transparency about how the final partition has been constructed, a summary table and reports are generated at the end of the process. For each person, we see the consolidated label along with the labels produced by the list of algorithms and what the decision was. Here is a sample of the summary table of the first case study. The rightmost column shows that the user used the Ilouvin time algorithm to put Eloy Antome in the Antome group. She also used the consensus of 8 algorithms to put Julien Girard in the Boucher group. Finally, she manually labeled Rose Boucher as being in the Boucher group too. The table provides a summary of the provenance of the results. It reports the size and distribution of the prior knowledge and the final partition. It then indicates statistics on how the nodes have been consolidated. Finally, it tells the number of algorithms considered and the number of algorithms selected by the user in the validation process. The summary table and the summary reports give a transparent result that the social scientist can use in her publication. PK clustering is a new approach to clustering. In a mixed initiative interactive process, it uses users' prior knowledge and proposes multiple alternative clusterings. As there is often no ground truth and several good clusterings may coexist, the user can choose the results which best fit his vision of the data. Like in any other method, biases are possible. But we believe that PK clustering provides a good balance between the advantages of algorithm power and taking users' knowledge into account. At the end, Users remain responsible for reporting and justifying their choices in interventions. PK clustering is available at the following address. Thank you.